Welcome to our data engineering course, and in this series of videos I'll talk about Docker and SQL. We'll start with Docker. This is actually what we will cover in that part. So we'll start with Docker. We'll tell you why we need Docker, why should we care as data engineers about Docker, and then after that we will use Docker to run Postgres, which is a database, a quite powerful database, which we will use to practice some SQL. And then in the meantime, while doing that, we'll also take a look at the data set we will use for this course. So this data set is this taxi rides New York data set. We'll take a look at this data set and we will use this for practice in SQL, and we will use this data set also throughout the course for building data pipelines and for processing this data. Okay, so let's start. We'll start with Docker. So let me just go to Google and look at what Docker is. So if I type in Docker, it tells you a bunch of things. The interesting one is that it delivers software in packages called containers, and containers are isolated from one another. So this is important for us, both things, containers and isolation. Suppose we have a data pipeline. We want to run this data pipeline in a Docker container. So this data pipeline is isolated from the rest of things. Let me start with data pipelines. So data pipeline is a fancy name of process, a service that gets in data and produces more data. And this could be, let's say, a Python script that gets some CSV files, some data. So let's say it can be CSV files, and then it takes in this data, does something with this data, some processing, some transformation, some cleaning, and then it produces other data. And this could be, for example, a table in Postgres with something else. So we have some input data and we have output. So, or this could be source and this could be destination, for example. And yeah, so this goes into our data pipeline. Of course, the data pipeline can contain multiple data sources. It outputs data to some destination. And of course, inside data pipeline, there could be many different steps that also follow the same pattern. We can have these mini pipelines that we can chain. And then this whole thing would also be called a data pipeline. Now let's focus on one particular step. So we have a script that gets in some data in CSV format and writes it to Postgres. And we want to run it on our computer, on a host machine. So this is host computer. I use Windows, but if you use Linux or macOS, this is the environment you have. And then on this host computer, you can have multiple containers that you run with Docker. So for example, one container could be this our data pipeline. And for example, for running this data pipeline, we need, let's say we want to use Ubuntu 20.04 for running this pipeline, and then there are a bunch of things we depend on in order to run this pipeline. So for example, can be Python 3.9, and then let's say if we want to read a CSV file, we will use pandas, which is a library in Python for processing data. And let's say this data pipeline will write the results to our Postgres database. So then the data pipeline needs to know how to communicate with Postgres. So it needs Postgres connection library and probably a bunch of other things. So we can put this in a self-contained container, and this container will have everything that this particular service, this particular thing needs. Version of Python, all versions of libraries. It will contain everything it needs for running this pipeline. And we can actually have multiple containers in one host machine. So for example, we can also run our database, Postgres, in a container. So we will not need to install anything on our host computer. We will not need to install Postgres. We will only need Docker to be able to run a database. It can also happen that we already have Postgres on our computer, on our host machine that we installed, that we don't use through Docker, but we just install it on our host computer. And in this case, this database and this database, they will not conflict with each other. So they will run in complete isolation. And what is more, we can actually have multiple databases running on our host computer inside Docker, and they will not know anything about each other. They will not interfere with each other. So this is quite good. We can have more things. So for example, For accessing, for communicating with Postgres, for running SQL queries, we will use a tool called pgadmin. We also don't need to install it. We can also use this from Docker. So we can just run this as a container on our host computer. We will not need to worry about installing anything. As long as we have Docker, we can just run this pgadmin and communicate with Postgres, run SQL queries, do testing, and so on. And another advantage that Docker gives us is reproducibility. So let's say we created a Docker image. A Docker image is like a snapshot sort of your container. It has all the instructions that are needed to set up this particular environment. So you have this Docker image and you can take this Docker image and run it in a different environment. Let's say we want now to take the data pipeline we developed and we want to run it in a different environment, in Google Cloud, in Kubernetes, or it could be AWS batch or some other environment. It doesn't matter. And we can take this image and just run it there as a container, and it will be the same container, exactly the same container as we have locally. So this way we make sure that we have 100% reproducibility, because this image and this image are identical. They have the same versions of libraries, they have the same operating system there, so they are identical. And this way we make sure that if it works on my computer, then it will also work there. So this is the main advantage of Docker. So why should we care about Docker as data engineers? Well, we already mentioned the reproducibility, so that's quite useful. Then setting up things for local experiments, this is quite useful. So this is what we are going to do in this series of videos. We will use Postgres, we will run it locally, so local experiments. And not only experiments, but also local tests, integration tests. So for example, let's say we have this data pipeline, which is a complex pipeline that is doing something with the data, and we want to make sure that whatever it's doing, we expect these results, so we can come up with a bunch of tests to make sure that the behavior is what we expect. And when we run this data pipeline against that database, and we go to this database to make sure that all the records we expect to be there are there, and records that we do not expect to be there are not there, these things are called integration tests. And Docker is quite useful for setting up these integration tests in CI/CD. This is not something we'll cover in this course. I think this is general software engineering best practices to have things like that. And yeah, you can look up what CI/CD is. For that, we usually use things like GitHub Actions or GitLab CI/CD or Jenkins, things like that. So you can take a look at that if you're interested, if you haven't come across this concept before of CI/CD. We will not be covering these things in this course, but this is super useful. I do recommend learning about this. And then many times when we write batch jobs like these data pipelines, we want to make sure that they are reproducible and we can run them. So let me move it here. And running on the cloud, it can be AWS batch, Kubernetes jobs, and then so on. So we just take our image and we run it on the cloud. And then things like Spark or serverless, we can specify in Spark. So the Spark is a thing for also defining data pipelines. So we can specify all the dependencies we need for our data pipeline in Spark with Docker. And then serverless, this is a concept that is quite useful for processing data, usually one record at a time. So these are things like AWS Lambda, and I don't remember, it's called Google Functions maybe, I'm not sure. But these things usually let us define the environment also as a Docker image. And you can see containers are everywhere, and for data engineers, it's quite important to know how to use Docker, how to use containers, to be able to run local experiments, to make sure they are reproducible, and to use in different environments. They are everywhere. Okay, by now I think I convinced you that Docker is useful, so let's see this in action. So right now I am in our course repo in week 1, basics and setup. So I will create now a directory. I'll call it Docker SQL. Let me cd to this directory. By the way, I think I mentioned I use Windows, and on Windows I use a thing called min.gw. I don't know how to actually pronounce this, but this is a Linux-like environment in Windows. So it has all these Linux commands like ls and others. And this min.gw comes from git bash. When you install Git for Windows, it comes with bash. It's called bash emulator, this min.gw, and I use that as a terminal. I think you can also use like standard command prompt or PowerShell, but I would recommend to actually use MinGV or Cygwin or something like this if you're on Windows, or you can use Windows subsystem for Linux, which could be even better. So I also have it here. So this is a usual Ubuntu, but I run it on Windows. You can experiment with both and see what you like. Yeah, on Mac you don't have this problem. You can just use the usual Unix terminal, and of course on Ubuntu or on Linux you don't have this problem at all. So I'm using Git bash. So what I want to do now is I want to execute to start my editor. For editing I use Visual Studio Code. Again, you don't have to use it. You can use something else. You can use PyCharm, you can use Sublime Editor, you can use Notepad++, you can use Vim, you can use whatever you want. If you don't have any preferences and if you don't know what to use, you can just pick Visual Studio Code. This is what I personally will use for that course. And here we can create a new file. So this file should be called Dockerfile. And this is where we will specify our image. Actually, before that, I wanted to show you something. Once you install Docker, you can test it using docker run hello world. And what it will do, it will go to Docker Hub. This is a place where Docker keeps all the images, and it will look for an image with this name, hello world, and it will download this image, and it will run this image. And what we see here, this is actually output from Docker from this image. Run this and it outputs something. It means that Docker works, and now it suggests to do something more ambitious. Let's say we can run that, Docker run Ubuntu. So run, it means that we want to run this image. -at means we want to do this in interactive mode. Interactive T means terminal. So it means that we want to be able to type something, and then Docker will react to that. So let's run this. And now what I mean by typing is, so you see I can type things here. So Ubuntu is the name of the image we want to run, and then bash is here is a command that we want to execute in this image. So this is like a parameter. So everything that comes after the image name is parameter to this container. And in this way we just say that we want to execute a bash on this image, and this way we get this bash prompt so we can execute things. And let's say we want to do something stupid here, like remove everything that we have in our image. So do this ref. And it says, yeah, it's dangerous. Okay, whatever. I want to execute it anyways. Yeah, so now I did a stupid thing. I don't even have ls, because ls is also a program. I deleted it, so I deleted this user bin. So I cannot even ls things. So I don't know what is left on this container. We don't have any files anymore. And let us exit this container and run it again. And when we run it, we are again back to the state that we were before. So this container is not affected by anything we did previously. This is what isolation actually means. If an app does something stupid, our host machine is not affected. Okay, so we again can do ls here. This is not super exciting. Let's do something even more interesting. Let us run Python, let's say 3.9. Here we specify the image that we want to run, and this is a tag. So tag, you can think of tag as a specific version of what we want to run. So this is a tag, and for us it means that we will run Python 3.9. Let me execute this. Because I already ran this image, it doesn't download it. It already used an image I have downloaded previously, but for you, if you use it for the first time on your computer, you will first see that it downloads an image and then runs it. And then we get this Python prompt, and we can do things like print hello world. We can write any Python code like import.os, and for example, we can do Python stuff here. What if we wanted to write a Python script? In this data pipeline, we'll need to use pandas. Actually, this one, right? So let's say it needs pandas. So now I write import pandas, and it says there is no module named pandas. So we need to be able to install pandas here. And what we usually do is something like pip install pandas, but we do this outside of Python prompt. So we can just do this in Python and install things there. So let me exit this. I pressed Ctrl D right now to leave the Python prompt. So now we somehow need to get to bash to be able to install a command. And for that, we need to override the entry point. Entry point is what exactly is executed when we run this container. and entry point can be, let's say, bash. And now instead of having a Python prompt, we have a bash prompt, and we can execute bash commands. And then we can do pip install pandas. And right now we are installing pandas on this specific Docker container. Yeah, it needs to install a bunch of things for pandas, so pandas depends on NumPy. Okay, now we installed pandas, and we can do Python now, and we enter the Python prompt, and we can execute things here. For example, import pandas, and now it works. So we can see what is the version of pandas, for example. Yeah, we can execute things here with pandas. The problem here is now when we leave it, so I press Ctrl D again. Now when we leave it and we execute this again and we run Python again and we do import pandas, there is no module named pandas for the same reason as our rmrf/. We were able to recover from this. So when we run this specific container at that state. So it was before we installed pandas. So when we run it again, it doesn't know that there should be pandas because this particular image doesn't have pandas. Even though we started the container based on this image, we did some changes, but the next time we start the container from this image, we get the same state as before running all these things. So somehow we need to add pandas to make sure that the pandas library is there when we run our code. So let me exit this. And for that, we go back to this Dockerfile that I created. So here we can specify in the Dockerfile, we can specify all the instructions, all the things that we want to run in order to create a new image based on whatever we want. The Dockerfile starts usually with the from statements. And in this statement, we say what kind of base image we want to use. So for example, we want to base our image on Python 3.9. Whatever we will run after that, we'll use Python 3.9 as a base image. And then we can run a command. So this command can be pip install pandas. This will install pandas inside the container and it will create a new image based on that. And then we can also override. So remember when we do docker run, we get Python prompt. We can override it and get bash. Entry point can be bash. Yeah, so this is the simplest possible Dockerfile with just two instructions. We install pandas and we override this entry point. Now we can build it. For that we do docker build. Docker build command builds an image from Dockerfile. It needs a couple of things. So first of all, it needs a tag. Tag could be, for example, let's call it test, and then we can just leave it like that, and the image name will be test. Or we can add a tag here, like a version could be test pandas or whatever. And then we need a dot at the end. Dot means that we want Docker to build an image in this directory, and in this directory, in the current directory, it will look for Dockerfile and it will execute this Dockerfile and will create an image with this name. So let's run it. Yeah, actually I was doing some experiments before. So you see that it says cached. So when you run this, it will be a little bit different. So it will actually run pip install pandas in Docker. You will see this. For me, I already did this yesterday when I was preparing the materials. So that's why for me it's cached. Maybe to see how it actually works, let me take a specific version of Python 3.9.1. I hope this version exists. And then let's see what happens. Yeah, so now it downloads this specific version of Python. And then after it finishes downloading it, it will also install pandas on top of that image. Now it's running this thing, so we can see the output, what it is doing. So it's installing dependencies for pandas. Okay, so now it finished installing. It took 2 minutes, and now we can run this. So let's do this. Docker run -it. We don't need any parameters here, so we'll run this image with this tag. And because entry point here is bash, we get a bash prompt here. And now if we do Python and do import, and you see that this is actually the version of Python we have. It's a bit an older version. It's almost 1 year old. So now when we do import pandas, it successfully can import pandas. We can also check the version of pandas, which is this version. So now we have this image. Let's do something a bit more exciting. So let me create a pipeline. This will be our data pipeline. In this data pipeline, we will use pandas. Usually the convention when we import pandas as PD. I don't know why, it's just people use it this way. So let's do this, and then we will do some fancy stuff with pandas, like loading CSV file. And yeah, let's just do print job finished successfully. So this will be our data pipeline that will do some fancy stuff with pandas. So for us, it will be just a way to check that pandas can be imported. It will not do much. And now we can copy this file from this directory, from our current working directory, to the Docker image. Line.py. So first we specify the name in the source on our host machine, and then the name on the destination. We can keep the same name. We can also specify the working directory. It's work directory. This will be the location in the image, in the container, where we will copy the file. So I'll just call it up. It will create a /up directory, and it will do cd/up to this directory, and then it will copy the file there. So let me execute it. So I will build it. I will keep the same tag, so it will overwrite the previous tag. Okay, that was quite fast because we didn't need to install pandas, so it used the cached version. And now let me run it. And now you see we're in this /up directory. So if I do pwd, this is our current directory. So current directory is /up, because this is what we specified here. And we have our pipeline.py file there. Now let me run it. And it finished the job successfully. But in order to call it like a data pipeline, this container has to be self-sufficient. So we don't want to run the container, go there and execute Python pipeline.py. We also want to add some parameters there. Like for example, we want to run this pipeline for a specific day. It will pull all the data for this specific day, apply some transformation and save the results somewhere. So let me configure it. I will use CLI. I think it's import sys and then sys argv. So these are the command line arguments that we pass to the script. So let me just print everything, like all the arguments, for you to see what can be there. And then I think the argument number 0 is the name of the file. The argument number 1 is whatever we pass. So let's say here we can have a variable that we'll call day. That will be the first command line argument. And we can say job finished successfully for day equals day. Yeah, let's see what happens. I will rebuild it again. One more thing I want to do. Okay, so now we specify this pipeline. I want to override this entry point. So I want to say that when we do docker run, I want Docker to do Python pipeline.py. So this is what I want Docker to do. So let me build it one more time. And now I want to run it. Now when I do this, it will run this pipeline. And I want to configure it to run it for a specific day. So let's say today is 15th of January. And when I write an argument like this, it will be an argument for the thing running in the container. Now let me execute it, you will see. So this is this argv thing, this one. So it shows all the arguments. And we use this day parameter. And then we see that our job finished successfully for this particular day. I don't need the F here. And if I put more arguments here, so let's say 1, 2, 3, hello. So all these arguments will be passed also to argv. You see, we have a longer list with more arguments. So this is how we can parameterize our data pipeline scripts. Okay, this I just wanted to give you a taste what we can do, and in the next video we will see how we can run Postgres locally with Docker, and we will also see how to put some data in this Postgres with Python. We actually will keep working on this pipeline script, and then we will Dockerize this script, and it will put this New York taxi rides dataset to Postgres. That's all for this video, and see you soon.